Good morning, everyone. Thank you for joining the Applications for Modified NTPs webinar. We're just going to go ahead and give everyone another few seconds to just go ahead and get settled and maybe some late stragglers to log on. And then we'll go ahead and begin the presentation. Okay, thank you everyone for joining the Applications for Modified NTPs webinar. I know everyone is very busy, so we do appreciate you taking some time out of your schedules to sit down and speak and learn from us. Let's go ahead and get started. So introductions. My name is Nicholas Coe, and I am a technical insight sales specialist here at TriLink. I will be presenting along with my coworker, Taylor McReynolds. Taylor, you want to tell us a little bit about yourself?
Hi, yes, I'm Taylor McReynolds. I am a senior technical sales specialist here at TriLink, specializing in our mRNA product line, and I look forward to presenting to you guys.
Okay. So NTPs, everybody knows that NTPs are the building blocks of DNA and RNA. And we all know that the industry has grown and learned a lot, tremendously within the past 20, 30 years. And at this point, we're at a point now where we can synthetically manufacture NTPs for use in research and clinical applications. TriLink does specialize in several NTPs. We've got hundreds of catalog NTPs, ranging from dye-labeled NTPs to methylated NTPs. It really just all flavors. So some current industry challenges. Everyone knows with COVID, there's a lot of uncertainty regarding supply chain. And one of the hardest parts is scaling production to your needs. TriLink supports research use to GMP material from micromole to kilogram size scale. We also offer something called GMP Link, which is an a la carte version of GMP. It's designed for a little bit more flexible or an in-between grade for those that do not require full GMP. What we've noticed is several of our customers, when they look for GMP, what they're actually looking for is GMP Link. And this is something that we can work with you to meet your needs on. TriLink is great for all stages, from research to clinicals. You know, as we said, we're able to scale our manufacturing programs to meet your needs. We're also able to provide custom chemistry, and we have over 25 years of experience in manufacturing for optimal mRNA and NTP performance. TriLink is ISO 9001 2015 certified, and we are ICHQ 7 section 19 for GMP with ISOs class 7 and class 8 rooms, as well as a class 5 fill and finish room. So diving in a little bit more about our offerings, we are able to offer custom NTPs, custom oligos, custom mRNA, as well as catalog mRNA and catalog NTPs, which is what we're going to be going into a little bit further. We are also able to offer small molecules and clean cap. And starting 2021, which is something that we're very excited about, is plasmid production. And what we really want to emphasize is that from discovery to clinical, TriLink is really your partner throughout this entire process. So just a little bit more about our facility. We had built this facility from the ground up in 2019 and recently moved in, I want to say December of 2019. You know, and we've been expanding out our 105,000 square foot facility to meet the demands of our customers. As we mentioned previously, we also have ISO class 7 and class 8 GMP customer suites for GMP. And applications for modifications. So today we will be talking about our catalog and custom NTPs, majority of these are offered as catalog products, and we can do some custom formulation for these as well. So labeling applications. Some of the most common NTPs, labeling NTPs, are biotinylated and dye-labeled NTPs. And we can see some of the uses that, the applications that they're useful for here. So the biotinylated NTPs are ideal for streptavidin-based pull-downs. They can be enzymatically incorporated into DNA via PCR, NIC translation, primer extension, or DNA polymerase, or TDT. And they're very effective in, they're also effectively incorporated when using the Maloney-Murine leukemia virus. So our dye-labeled NTPs, these are ideal for fluorescent detections, and they are commonly incorporated into our mRNA as well, both custom and catalog. And they act as a substrate for the T7 RNA polymerase, allowing for the incorporation of the dye labels into RNA and mRNA. Specifically, I'm speaking about the cyanine modifications. So primary amines. So we also offer amino alleles and propargyl aminos. And what we have seen is the propargyl aminos have been extremely more common than their amino allele counterparts for NGS. And these are these can be used in NGS workups. Epigenetic applications. Modified NTPs can be used to mimic a wide variety of epigenetic mechanisms, such as methylation. And methylation is a very widely studied epigenetic modification, and we also offer ACGU modifications as well as some more complex modifications for these NTPs as well. DNA damage. So as we know, DNA can be damaged in a variety of ways, and these damages can be frequently associated with results that are not anticipated. So what we can go ahead and do is replicate these results and these damaged NTPs to study downstream signaling. Nuclease resistance. Incorporating these modified NTPs can make mRNA more resistant to degradation. A lot of this is due to some of the chemical stability associated with it. 2'-O-methyl, so methylation at the 2' position of the ribose sugar conveys increased stability of the resulting mRNA. And we have a couple of examples of these NTPs here. We also have alpha phosphates, where obviously the primary oxygen is replaced by a sulfur group, and this also increases the stability of the resulting mRNA. And I'm going to go ahead and hand the presentation over to my colleague Taylor to go ahead and speak a little bit further on the mRNA production.
Thank you very much, Nick. Appreciate all of that insight. Like Nick said, my name is Taylor McReynolds, and I'll be discussing NTPs in the context of mRNA and mRNA therapeutics. So mRNA is an increasingly popular method being used in vaccines, gene replacement, cell therapies, and more. There's three main considerations when designing mRNA for your therapeutic use. One, you'd like to reduce nuclease degradation. Two is you want to avoid the innate immune response. And three is simplifying and making the manufacturing process more efficient. So first, we are going to discuss some of the NTPs that can help with innate immune evasion. So pattern recognition receptors can identify mRNA that is seen as foreign and stop or inhibit translation. Modified uridine triphosphates can help to avoid this, which is very important for certain therapeutics. So here we see EGFP mRNA expression and how incorporating different modified UTP analogs can lead to increased expression. You can see that a number of different cell types were tested, and it's important to note that different modifications might work better or worse in certain cell types. So first I'll discuss pseudouridine, often referred to as the fifth nucleoside. Pseudouridine is one of the most commonly used UTP analogs for increasing expression and decreasing innate immune response. So there's another version of pseudouridine where an additional methyl group is added onto pseudouridine. It's called N1-methyl pseudouridine. You can see here that N1-methyl pseudo-U, which has been shown, N1-methyl pseudouridine has been shown to outperform pseudouridine in certain applications and cell types. The final UTP analog I'd like to talk about is 5-methoxy-UTP. 5-methoxy-UTP has also been shown to reduce immunogenicity. There have been some studies that have shown that it reduces innate immune response without the need for HPLC purification. HPLC purification can help reduce double-stranded RNA, but it also causes degradation of the mRNA and can significantly reduce the yield. So eliminating this step can be very, very useful. So here we see a comparison of wild-type mRNA that's been HPLC purified to 5-methoxy-U modified mRNA that is not HPLC purified. We see the 5-methoxy-U expression is not only high, but the expression persists for longer. So finally, we will be talking about cap analogs, which are NTP-like compounds used to incorporate the 5' cap onto an mRNA. First, it's important to understand the different cap structures, cap 0 and cap 1. Cap 0 on the left, you can see that the 2' position of the first sugar contains a OH. This is not found in higher eukaryotic mRNAs, and most, if not all, mature eukaryotic mRNAs have the 2' O methyl group in this first sugar position. And this structure is called cap 1. Cap 0 can be recognized as foreign and activate pattern recognition receptors. So it is not necessarily ideal for mRNA. So there's two methods of capping. So how do we go about putting a 5' cap on an mRNA? One bucket is enzymatic capping, in which we use a set of enzymes from the vaccinia virus that do capping and methylation at the first position. However, these enzymes are expensive and can vary in their efficiency. And also they add a step to your mRNA manufacturing process. So people have developed another way of doing this by doing what's called cotranscriptional capping, in which we include a cap analog in the mRNA transcription reaction. That cap analog caps as the RNA is being transcribed. There was a first generation cap analog still used some today called anti-reverse cap analog, or ARCA. But today I'm going to be focusing on TriLink's revolutionary method for capping RNA cotranscriptionally called clean cap. So first, let me tell you how ARCA works. The ARCA molecule is a dinucleotide cap analog. The cap analog can sit down at the +1 position of the T7 promoter and initiate transcription to add the cap. However, during that process, GTP, which is in the reaction to extend transcription, can also initiate at this same position, the same +1 position. You have a competition between the cap analog and the GTP. So in order to have efficient capping, we would have to put a large excess of the cap analog and reduce the amount of GTP. We at TriLink came up with this new method of cotranscriptionally capping called clean cap. So instead of being a dinucleotide, you can see here it's a trinucleotide. So this means that the cap analog sits down at the +1 and +2 position of the promoter to initiate transcription. Because of the affinity of that interaction is higher than with the NTP, and because we have chosen an NTP at the +1 position, which is not desirable for T7 transcription, in this case ATP, we can actually use an excess of GTP over the cap analog and still get efficient capping. The result of this is that we get about 2.5 times the yield of arca transcription. In fact, when looked at the capping, we get 3 times as much capped RNA from a given amount of T7 transcription. So this cap1 structure also leads to less innate immune response, and when combined with modified NTPs, can optimize mRNA performance. So in summary, TriLink offers a wide range of NTPs and NTP modifications, and these exist to support different research and therapeutic applications. We offer over 150 catalog modified NTPs, as well as custom synthesis. TriLink reagents and services enable optimized mRNA manufacturing through discovery and clinical and GMP requirements. So here you can have you see some contact information if you're interested in getting a quote or have any technical questions. You see mine and Nick's contact information below, and we'd be happy to answer any of your questions. So at this time, I'd like to thank you guys for attending the webinar. And at this point, we will be opening the floor for questions. So please feel free to submit any of your questions through the webinar application. And thanks again.
Okay, I think we're just going to go ahead and wait, maybe 30 seconds while people kind of gather their thoughts and maybe, jot down some questions that they might have. And then we can go ahead and move into the Q&A section. Okay, great. So we have a couple of questions here. One of the questions is, can I order the catalog material in GMP grade? And yes, you actually can. This is just reflective on some of our manufacturing capabilities and TriLink's commitment to quality. So, we are able to support, like I had said in the presentation, scales from micromoles to kilogram size quantities. And that's both in research use only and GMP scales, as well as the GMP link. Something that I would like to go ahead and mention is that we are also able to really do some process development with either these custom, these GMP catalog products, or even your custom chemistry products. And we've done this several times with several different companies. And really, we do a lot of the research and the development on scale up and the stability studies as well, to really make sure that we are able to get the most efficient yields possible.
Thank you, Nick. So next question we have here is, what is there intellectual property around CleanCap? Is there intellectual property around CleanCap? And so yes, there is. TriLink owns the patent for CleanCap, and we only require a one-time licensing fee, and that would be actually at the time of commercialization. So we make it easy for you to license it like that, and it is currently being used in many clinical development programs.
Okay, another question that we received is, what is CleanAmp and how is it different than standard unmodified NTPs? Then that's a great question. In this presentation, we really didn't talk about CleanAmp at all. But CleanAmp essentially is a hot start PCR that's an alternative to hot start DNA polymerase. And it enables hot start via chemically modified DNTPs and primers with the Taq DNA polymerase. There's a lot of different applications for this. It can be used in real-time PCR, reverse transcription PCR, GC-rich PCR, digital PCR, and moving into the question of what is the difference between this and unmodified NTPs. Our CleanAmp products were really designed to reduce primer, dimer, and mispriming while increasing the specificity of the desired product. With a more desired product, it also reduces the amount of data fluctuation and gives more consistent results as you're looking as you're looking at your product.
All right, thank you, Nick. So next question we have here is, how are modified NTPs incorporated into mRNA? So really, it's pretty simple. These modified NTPs can be added in place of your normal wild type NTPs in your transcription reaction. So if you have a transcription kit and say it calls for 5 millimolar of pseudo UTP or of regular UTP, you would just simply not use the wild type UTP and replace it with something like pseudo UTP or 5-methoxy UTP.
Okay. Another question that we have is, can you provide custom formulations of your catalog products? And the short answer is yes, we can. And the longer answer is we are able to do it within reason, within the catalog product line. So if we need to go ahead and use different aliquot requirements or something like that, we can most absolutely accommodate that. But once we start moving into adjusting the concentration, using different buffers, or in terms of mRNA, changing the NTPs like Taylor was saying, by swapping out U with pseudouridine, that would be considered a custom product. And those, while we are able to do that, it does not fall within our catalog product line, which is kind of what we were focusing more on today. But having said that, these are things that we are very familiar with and we do on a near daily basis.
All right, I have another question here about modified NTPs. Do modified NTPs affect the yield of transcription? So some do and some do not. Some NTPs with larger bulky side groups can have lower yields when doing T7 transcription, but others can have efficiency comparable to using wild type bases in your T7 transcription. So it really just depends on which NTP you're using. Some of our more common ones like the pseudo-U's and the N1-methyl pseudo-U don't have a huge effect on yield.
Okay, another question we have is regarding logistics, in regards to shipping CleanCap mRNA, around the world. We are able to go ahead and ship wherever, I guess most efficiently wherever FedEx does deliver, because that is our primary shipper. But we have shipped to more difficult regions using specialty couriers who specialize in the transport of biomaterials across the world. So short answer, yes, we can ship nearly anywhere in the world. Some places just might be a little bit more expensive than others. Okay, I think we have time for maybe 1 or 2 more questions.
Yeah, so one person is asking, what are the benefits of co-transcriptional capping over enzymatic? So one major benefit is that co-transcriptional eliminates the processing steps. The issue with past cap analogs and co-transcriptional capping is that it doesn't get as high of yields. So clean cap eliminates this problem because you get as high capping efficiencies and comparable yields to enzymatic capping. So it reduces cost while maintaining high yields and capping efficiencies.
Okay. Unfortunately, I think that's all the time that we have today. I apologize if we were unable to get to your question. However, we will reach out within the next couple of days with an answer. So please be on the lookout for that. Again, thank you everyone for attending this webinar. And we look forward to hearing from you soon and hope that you guys found this informative. Thank you very much.
Thank you all for attending, and have a great rest of your days.